All right, hello everybody. We're going to take a look at the 6-2 worksheet today about kites and trapezoids. We do have some proofs here to start us off today. We want to write a 2-column proof to show that the diagonals of a kite are perpendicular. So we're going to start, of course, with our 2 columns in our 2-column proof. We're going to write those in. And we've got our statements. And we've got our reasons. So starting with statement number 1, that's our given information. Our given information can be found from the diagram today. Our given information is that WX is congruent to WZ, and also XY is congruent to YZ, and that is given because it's a kite. So then, for step 2, I can say that I know that W and Y, both of these points, are on the perpendicular bisector of XZ. So this line is the perpendicular bisector of XZ, and I can say that because of the perpendicular bisector theorem. So W and Y are on the perpendicular bisector of XZ, because I know that W and Y are both having their points are both equidistant from the corners of X and Z. So Y is equidistant here from X and Z. W is also equidistant from X and Z. And again, that is our perpendicular bisector theorem. Perpendicular bisector theorem. So step 3 then, because again we're looking to see if these are perpendicular lines, I can say if W and Y are on the perpendicular bisector of XZ, then the line that connects them, WY, is the perpendicular bisector of XZ. I know that line must be the perpendicular bisector of XZ, and I know that because if we connect those 2 points, we get a line. So 2 connected points make a line. And there's a bunch of things that you could have said there, but that's one way to describe that. And so finally, step 4, we know that WY is perpendicular to XZ because we knew that it was the perpendicular bisector. So we're using the definition of perpendicular bisector. Perpendicular bisector. And then we're done. And of course, you might have a different proof than me. It might still work. Just make sure to check if you're not sure. Number 14. What is Emery's error? Emery says that BD is the perpendicular bisector of AC. So that means that HC must be equal to 8 because AC is equal to 16. But the problem with that is we don't know that BD is the perpendicular bisector of AC. Emery says it was, but BD doesn't actually bisect AC. B is not equidistant from A and C, so B is not on the perpendicular bisector. D is not equidistant from A and C, so D is not on the perpendicular bisector. So we'll write that. Points B and D, points B and D are not equidistant from A and C, so BD is not the perpendicular bisector of AC. The perpendicular bisector of AC. Simple as that. We can't go further because it's not the perpendicular bisector. Number 15, we've got another proof. Given kite JKLM with diagonal KM, and knowing that JK is shorter than JM and KL is shorter than LM, prove that angle JMK is congruent to angle LMK. So we've got a lot going on here. So let's make our proof. We've got our statements and our reasons, first of all. Hopefully I gave myself enough room. Statements and reasons. Well, the first thing that we know is that JKLM is a kite. Is a kite. And we know that because it was given. We also know, as given information, that JK is less than JM. And we know that KL is less than LM. We know that because it was given. So I also know that this is a kite, so I can infer some things based on the definition of kite. I can infer that JK is congruent to KL, because I know that JK is not congruent to its other adjacent side, JM. It already told me that. And I can also say that MJ is congruent to ML, because I know that that KL is not congruent to ML, so MJ must be congruent to ML. And I know those things because every kite has two pairs of adjacent congruent sides, so I know this because of the definition of kite. Then finally, or continuing on, I know that the diagonal KM is congruent to itself. And I know that because of the reflexive property. Well, now when I look at this, I have three congruences. I have this side congruent to this side congruent to this side, and this side congruent to this side. So I can say the triangles are congruent. Triangle KJM, KJM is congruent to triangle KLM, and it's congruent by side, 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 because they have three congruent sides. So since those triangles are congruent, I can state for certain that they're angles. Angle JMK is congruent to angle LMK, and I can say that for sure by CPCTC. And now I know that angle JMK and angle LMK are congruent. Number 17, given kite RSTU, what is the measure of angle RUS? Well, I know that the diagonals of a kite are perpendicular, so I know that the angle in there is 90. So I can do 180 minus 27 minus 90, and I can get 63. So I know that angle RSU is 63 degrees. And since these are going to be a pair of congruent triangles, this triangle right here and this triangle right here, congruent by side angle side, then that means that this triangle down here is also going to be 63 degrees, or that angle RUS is going to be 63 degrees. A lot of things with kites can be shown because kites are symmetrical. So we can figure out a lot of these answers without quite so much work because we know which sides and angles will be congruent based on the symmetry of a kite. Number 20, given trapezoid WXYZ, what is XY? So XY is this spot right here at the top. Maybe I'll call that A. I'll call it A. So that means that I know that the top side and the bottom side divided by 2 is going to give me the median. So A plus, if 4/3 XY is 4/3 times this side length, then I can call that 4/3 A. Just like that, because that's 4/3 times the top side. Divided by 2 gives us our median of 35. So I'm going to go ahead and simplify. A plus 4/3 A would be 3/3 A plus 4/3 A. That's 7/3 A over 2 equals 35. I can go ahead and multiply both sides of this equation by 2, which is going to give me 7/3 a equals 70. And then I can solve this. I could multiply both things by 3. So that's going to be 7a equals 210. Divide by 7. And a equals 30. Of course, you're more than welcome to solve it any way you'd like. But that means that a is 30 feet. We've got our units there. We should include them in our answer. Number 21. Gregory plans to make a kite like the one shown. Like I explained to you one time before, most of our story problems involving kites are about actual literal kites because we don't see the shape kite very often in everyday life. So Gregory wants to make a kite like the one shown. He has 1,700 square inches of plastic sheeting. Does Gregory have enough plastic to make the kite? And explain. So we're going to want to find the area of this kite because that's going to find the square inches of plastic sheeting. So we know that the diagonals of a kite are perpendicular, which means we have a whole bunch of right triangles here. I also know that this side of the kite will be bisected. It'll be the perpendicular bisector. So that 30 inches is going to be split into 15 and 15 inches. That's going to make it very easy for me to find the top of this kite. Okay? It's also going to make it pretty easy for me to find the missing side lengths that I have here. So let's find the missing side lengths first. I'm going to find this piece right here. I've got two sides that I know of a right triangle, so I can use the Pythagorean theorem. Say a squared plus 15 squared equals 17 squared. A squared plus 225 equals 289. So a squared equals 64. Take the square root of both sides. A equals 8. So this missing side is an 8. I should also do the missing side of my larger right triangle, which has side lengths of 15 and 39. So I can say a squared plus 15 squared equals 39 squared. So a squared plus 225 is going to equal 1,521. Subtract 225 from both sides. And a squared is equal to 1,296. We'll take the square root of both sides and find out that a is equal to 36. So this bottom part is equal to 36. So I can find the area of of all four triangles. I have two small triangles with a base of 15 and a height of 8 over 2. And I have two large triangles with a base of 15 and a height of 36 over 2. So that's going to give me altogether, those two small triangles would be 120, plus those two large triangles would be 540, and I get 660 inches squared. Since Greg has 1,700 square inches, then he definitely has enough plastic. So we can say yes, he has enough. Can she spell the word enough? Enough plastic. All right. Moving on. Number 22. Coach Murphy uses the map to plan a 2-mile run for the track team. How many times will the team run the route shown? So we got to figure out how long this route is, and we've also got to figure out our yards to miles conversion. So I will tell you that there are 1,760 yards in 1 mile, and that's going to help us out. So first, let's figure out how long this track is. The only side it looks like we don't know is the length of Mulberry Street. And since this is a trapezoid, I am going to be able to find the length of Mulberry Street since I know one of the bases of the trapezoid and the median. All right, so when I know this one base and I know the median, and I know it's the median because it's cut in half, 48 and 48 right here, then that means that I'm going to say, let's see, 48 plus 48 plus 46 plus 80 plus 80 plus the missing side. Oops, I forgot I need to find the side of Mulberry Street first. Let me do that first. That's going to be our base, 46, plus our missing base of x divided by 2 is going to be equal to our median of 92. So that means 46 plus x equals 92 times 2, which is 184. Subtract 46 from both sides. X equals 138. So 138 yards is the length of Mulberry Street. I'm going to add that into my calculation of the perimeter of this route, so plus 138. And altogether, this is going to be 440 yards. So I need to figure out how many times they can run the 440-yard track that will make 2 miles. So first, I'm going to find out how many yards are in 2 miles. So I'll say 1,760 times 2 equals 3,520 yards in 2 miles. Then I'll do that amount, 3,520 yards, divided by the 440-yard track. And that gives me 8 laps around the track to make 2 miles. Number 23, Abby builds a bench with the seat parallel to the ground. So we know those parallels, which means we know some stuff about these angles. She bends the pipe to make leg and seat supports. At what angle should she bend the pipe? Well, we know that these angles, 102 and the same side interior angle right here, will be supplementary. So we know that that's 78. Since these are parallel, we can say, well, this is going to be a trapezoid, and that means that the other side, since they're parallel here, will also be 102 and 78. So we can say 102, 102, 78, and 78, because she'll make an isosceles trapezoid with parallel bases this way. So she will make an isosceles trapezoid with parallel bases this way. And then finally, given trapezoid ABCD, what is the length of XY? So I can solve this by finding the length of the median. I can say that my large base, 6s plus 1, plus my small base s over 2 will give me the length of my median, 4s minus 2 rather. And so I'm going to go ahead and combine my like terms at the same time as I multiply everything by 2. So that's going to be 6s plus s. That's 7s plus 1 equals, because we're multiplying by 2, 4 times 2 is 8s, minus 2 times 2 is 4. And then we'll solve this equation. So 5 equals s. And it says, what is the length of xy? Xy is 4s minus 2. So 4 times 5 minus 2 is 20 minus 2. That is 18 units. So E is going to be the answer here. All right, and that is everything. Let me know if you need any help, if you have any other questions. Otherwise, see you later. Have a wonderful day.